The Babylonian system of numeration originated around 2000 BC. It is a base 60 positional or place value system. The positions for a base 60 system going from right to left would be 60 to the 0 power, or 1, 60 to the first power, or 60, 60 to the second power, or 3600. If we needed to go higher, it would be 60 to the third power, or 216,000. The symbols themselves are multipliers. They tell us how many of each of these powers of 60 are needed to represent the number. So for this, we need to find ways to represent numbers from 1 up to, but not including the base, so 1 to 59. So I'll start out. They use a simple additive or repetitive method for forming their multipliers. So this is 2, 3, 4, 5, 6. But when we got to 7 or more ones, they used a subtraction symbol. So the subtraction symbol is kind of a combination of symbols. That would be a subtraction symbol. So for 7, we'll go to the next higher multiple of 10. In this case, it would just be 10. And we'll subtract the excess, so subtract 3. So 8 would be 10 minus 2. 9 would be 10 minus 1. And then, of course, there's 10. Now, 11 would be a combination of symbols. So it'd be 10 plus 1. 12 would be 10 plus 2. All right, so let's skip down to 38. Well, 38 has 7 or more 1, so we'll go to the next multiple of 10. I'll go to 40. 10, 20, 30, 40 minus 2. 59, all right, that's 7 or more 1, so I'll go to 60. 10, 20, 30, 40, 50, 60 minus 1. So if I wanted to convert the Babylonian numeral to a Hindu-Arabic numeral, the first thing I need to do is identify the values of the position. So the first position in the far right would be 60 to the 0 power, or 1. The second position going right to left would be 60 to the first power, or 60. The third position going right to left would be 60 to the second power, or 3600. So the symbols are multiplier. They answer the question, how many? The positions answer the question, what? So I need 2 of the 3600s, 3 of the 60s, and we have 10 minus 3. So it's 7 of the ones. So simplifying this, I have 7,200 plus 180 plus 7. And that gives us 7,387. Now, if I wanted to convert a Hindu-Arabic numeral, 95,346, to a Babylonian numeral, again, I need to know how many of each of these powers of 6 go into a number. So I'll start by identifying the values of the positions. So from right to left, 60 to the 0 power is 1, 60 to the first power is 60, 60 to the second power is 3600, 60 to the third power is 216,000. Well, I don't need any 216,000s because they're bigger than a number, so I'll eliminate that. So let's see how many 3600s. So I'll divide the 3600 into 95,346. Okay, I see I need 26 of them. So I'll multiply 26 times that 3600. I get 93,600 with 1746 left over. So 26, I'll write that as 20 plus 6. So 10, 20, 1, 2, 3, 4, 5, 6. Then I need to know how many of the next largest group, 60s, are in what's left over. So 60 into the remainder, the 1746, and I need 29 of those. Well, 29 has 7 or more ones, so I'm going to go to the next higher multiple of 10. I'll go to 30, and I'll subtract 1. So 10, 20, 30 minus 1. So 29 60s is 1740 with a remainder of 6. So I need to know how many ones are in what's left over. Well, 1 into 6 is just 6. So that's 1, 2, 3, 4, 5, 6. That's our Babylonian numeral.